seatbelt and he crashed the car.
Yeah. Electric meters, okay? In terms of how they do it, we'll briefly go over it. In terms of the training of it, these meters are read by the building automation system. Going through and touching buttons on the top of the screens is not going to interfere with anything of that. But there is a way that if you just keep pushing these buttons, you can get into the programming level, and it stops talking to the BAS, and everybody's now going up. The information that's displayed on the meters, depending on what's being pulled by the BAS, it's either mirroring the meters or sections of the meters. I just don't know what they have displayed at their head end, okay? The meter is a microprocessor-based meter. It does the thinking. It has firmware. Inside the meter is also a RAM memory chip. There's no batteries for memory in the meter. Every 2 seconds, the processor compares the active piece of firmware to the firmware that's in the RAM memory chip. Does check something and says, okay, I'm still thinking correctly. If the meter, you come to any one of these, it's blank. Okay, not that the LCD screen, that the light's off. Nothing's on it. That means it failed. It will shut itself off. So 99.9% of the time, nothing's ever 100% accurate, 100%. When the meter's up and running, it's within the accuracy standards. The meters came pre-programmed to the job site. At that point, electricians went and threw the current transformers onto the meters, hooked them up. At that point, good to go. In terms of the information displayed, they're all on the same screen and we're on different screens. There's a default screen. God only knows what people want them to be set at. Okay, so we just did voltage or amperage, have a nice day. But basically, when you go through the meter, it's the center button. There's usage and parameters, volts, amps, THD, the whole 9 yards. Okay, so usage-wise, in this case here, we got volts. You got phase-to-phase volts, phase-to-neutral volts, amps, and so on. kW, kVA, it's all good. Let me check something here. Okay. I'm just want to get an idea of what the loads are doing. So basically, right now, not so much things on. Not too many things are on. Some things are on. Cycles on and off. We have no idea what we're looking at in terms of what these meters are doing. Okay, no sweat. All right. So at that point, once they start ramping up usage, the kilowatt hours would be displayed. Also on the meters is kVAR hours. Okay, both leading and lagging. Okay, and that's just where the amperage is over voltage or behind voltage on the sine wave. Reactive power, wasted power, useless power, power that's created by the load that the transformer has to generate in order to get the kilowatt hours through. It's just a function of the power. Okay, nothing in this school is any different than anything else, including your house. Not to the extent because we don't have all this mechanical equipment and a ton of DC controls and VFDs, which this place has, I'm assuming. But that's where the more of that kind of load that you have, the more loss in terms of reactive power you're going to consume. Okay? So far, everybody good? Okay. I'm not going to open up the cabinets. I'm not licensed in this state. But what we have to the meters is we have a common feed to the meters, or a feed to the meters from the auxiliary power supply to turn the puppies on. And we bring 3 phases to the bottom for measuring circuits, neutral if it's available, if not, okay. And then 3 current transformers. In as much as Ohm's law is a given, okay? It's called Blondell's theorem. That's also a law. It's a given. Where volts times amps off the same phase equals VA, you throw in some power factor and you have watts. So whether it's this meter or any other meter that's out there, we all work with Ohm's law and Blondell's theorem. End of story. Whether it's a $200 meter or a $30,000 meter, it's the same stuff. It's just a matter of how much stuff is displayed and what the meter can do. Okay? At that point, again, the reason that all the displays are lit is that I program them to be lit all the time. Because a lot of the situations in the past, or applications in the past, where you shut them off, and they go, well, it doesn't work. Well, the light's off. So I kept them all on, and oh, everything works. So at that point, it's just LEDs, there's no heat, it's all good, okay? In terms of the warranty of the meter, we'd say 5 years. This particular meter has been out since 2007, and they've been out in the field since 2007, okay? Our first generation was in '87. We switched to 2004 because you all changed your standards. So we have all these meters and then some. So it's 04 on as that I can talk. So we're good for about, 10 to 14 years so far track record, depending on the model of the meter. Okay? In terms of any questions, when the information starts being read by the BAS, or if the BAS is going to be using this information to control the building, if anybody's got any question, call me. Okay? At that point, we work it out in terms of what numbers make sense, don't make sense, or whatever. Okay? Even though, there's a 5-year limit, 5-year warranty, that doesn't have to do anything with the support. We got 800 number, I can give you you have my cell phone. At that point, call me. Okay? I do stuff on weekends and nights just like you guys do. Okay? Got a question? Call. End of story. At that point, in terms of the overall install, seeing how the guy is right here, there's nothing wrong with this. At that point, looks-wise, again, not opening it up, it's all good. At that point, heat is not going to have an issue. Yes, we have some hot things in this room, but other things are going to have more of an issue than these if it gets that hot. Okay? Worst case is, just like the old watches back, the old LCD screen watches back in the day, they're going to turn black. Cools down, they come back. We don't have to worry about cold weather because they just go blank. So to answer your question before you think about it, 33 degrees to 120 degrees is the LCD display. Negative 14, this is all Fahrenheit, negative 14 to 165 is the operating temperature of the electronics within the meter itself. So it's not going anywhere, okay? Especially here, it's hot, hey, it's all good. What else? Okay, current transformers that are connected to the meters that are around the phases that are in the panels or switchboards, wherever they are. 1% accurate CT. So at this point, the meter being 0.2, the CT being plus or minus 1%, out of the package, it's 1.2%, okay, plus or minus. It's usually on the plus side in terms of accuracy, never on the minus. You can't have a CT that works even better than what it should. Not so much. So, but given that at that point, wiring to go to the CTs and, a little bit of voltage loss or wire size or whatever, install plus or minus 2% as is the ANSI standard, okay? That's what sub-meters are. These, if they ever get tested by anybody, they'll probably come out a little bit better, okay? But they won't be any worse. CTs were, hold on, because I can't remember everything, so I wrote down, oh, here it is. What we got here, meters and closures, so they're going to be, most of them are solid core CTs, except for 2000 amp ones, which are probably in here somewhere, or split cores. So outside of that, programming wise, don't. In terms of touching them, sure. Okay, you really have to get lucky to get down into the programming level, but it's not impossible. That's the only thing that bothers me. If these things are talking to the BAS, we're going to stop them. We're going to just shut them off from the BAS. Okay? What else?
What do these run off for? Current sensor? Or?
Current sensor, current transformer, okay. 5 amp secondary. So if it's a 200 amp, if the meter was programmed for 200 amps because it was 200 amp load, probably have a 200 amp, 200 to 5 on it, 400 to 5, 2000 to 5 current transformers. Reason being is the utility standard, 5 amp CTs, so everybody kind of uses them in the sub-metering world except one company.
Yeah.
Everything's labeled in terms of the accuracy of the CT for NCC 5713. I don't know, you got your phone, I got mine. They have to be labeled with part number, manufacturer, accuracy, burden, VA. All that information is labeled on the CTs. As years go by, depending on how hot the enclosure is, where the CTs are, sometimes the label gets the glue gets a little dry and the label kind of moves down on the floor somewhere. But right now, they're labeled. 5 to 10 years from now, that's literally, unless you have any terms of power quality or parameter questions, the meter will do and calculate until it goes out of calibration, and that's, again, a checksumming of the firmware, what's being used against what's in the RAM memory chip. If the meter decides to go bad, it will shut itself off. The other reason that it will shut itself off is that there's a transformer in the meter that will bring power from the auxiliary power supply from whatever down to millivoltage. If that transformer ever decides to have a bad hair day, take off, whatever, there are traces on the board that will melt open at less than 0.2 of an amp, feeding the voltage to that primary side of that transformer. So it'll melt open, it'll shut off, but no way there's going to be a fault going to the breaker or fuses that are feeding these meters. Okay?
It doesn't affect the operation of the breaker. If that shits the bed.
That's just that's gone.
Okay.
Okay? Or that one at a time. The only thing that I saw in probably a year and a half, 2 years ago, but it was upstate Pennsylvania, it was out in the middle of nowhere, is that this building just got, or actually it's a mall, Gettysburg, got hit by lightning.